Good morning, everybody. You are welcome to the stream. Good morning. All right, so good morning, Treasure, good morning, Oyibe, good morning, Desire. You're welcome. Okay, so trigonometry 2 talks about trigonometric ratio. Okay, so when normally we have sine theta, cos theta, tan theta, sec theta, cosec theta. Good. Okay. So when you have all of this, what comes to your mind is, and you have a triangle this way. Here is theta, here is radius, here is A, and here is B. This side is opposite, hypotenuse and adjacent. So we have so ka toa, and so ka toa depicts opposite over hypotenuse, opposite over hypotenuse, and ka means adjacent over hypotenuse. Tan means opposite over adjacent. Okay? So, if that is the case, sec theta means 1 over cos theta. Cosec theta means 1 over sine theta. Cot theta means adjacent all over opposite. So sec theta means 1 over cos theta, that means hypotenuse over adjacent. The 1 over sine theta, that means hypotenuse over opposite. See it here. Sec theta means hypotenuse over adjacent. Cosec theta means hypotenuse all over opposite. Jessica, good morning. Jessica, you're welcome. Chiduben, good morning. Olebube, good morning. Anastasia Obaji, good morning. You all are welcome. Ugu Kindness, good morning. You all are welcome. Our number 1 today, Anastasia is number 1. If you are number 1, you get a prize immediately. Johnson, you're welcome. Ifeanyi Chukwu, you're welcome. Good morning, all of you. So let's pay attention to trigonometry 2. Now, because we have known that sine theta, cos theta, soc toa, opposites, adjacent, saga, we have to say that sine theta is equal to opposite is A over B. over r, sorry. Cos theta is equal to b over r, adjacent over hypotenuse. Then tan theta is equal to opposite over adjacent. All right. We need to prove something very important. For a right angle triangle, this side is 90 degrees. We have what we call Pythagoras theorem. Hypotenuse square is equal to opposite square plus adjacent square. But if you divide both sides by r squared, this will cancel and it will give us 1 equal to a squared over r squared plus b squared over r squared. Having known that sine theta is equal to a over r, we have sine squared theta will give us a squared over r squared. Cos squared theta will give us b squared over r squared. Comparing it with Pythagoras theorem, we have sine squared theta plus cos squared theta equal to 1. So we have proved the first identity, trigo identity. We have proved the first trigo identity. Keep on liking. Good morning, Jessica Nweze. Like, share. Anastasia, welcome. Naji, Joy, you're welcome. All right. Since the trigo identity, the fundamental trigo identity, sine squared theta plus cos squared theta is equal to 1. Sine squared theta plus cos squared theta is equal to 1. We have like sine squared theta is equal to 1 minus cos squared theta. Okay? We have that sine squared theta is equal to 1 minus cos squared theta. Now, cos squared theta is equal to 1 minus sine squared theta. Okay, so you find out that from here, we can say divide both sides. Divide everything by cos theta, cos squared theta, cos squared theta, cos squared theta. So that when you do, you will notice that this will cancel out this. Sine theta over cos theta is tan squared theta plus 1 equal to 1 over cos is sec squared theta. Okay, so from here, we can also say that tan squared theta is equal to sec squared theta minus 1. Good morning, Cypra. You're welcome. Another trigo identity. Okay, and so on and so forth. We generate as many as possible. What if we divide through by sine theta, sine squared theta? Dividing both sides by sine squared theta, we already know that all right. So this can cancel out this, and we have 1 plus cot squared theta is equal to cosec squared theta. Now, there is what we call 1 minus cos squared theta over sec squared theta minus 1. So this is equal to what? What is the answer? Full network is disturbing. Maybe I should close them. All right, so keep on sharing, liking, keep on liking. All right, so have you finished solving it? Let's solve it together. 1 minus cos squared theta over sec minus 1. So from what I have told you before, sine squared theta is equal to 1 minus cos squared theta. Sec squared theta minus 1 is equal to tan squared theta. Okay, so copy and paste sine square theta over tan square theta is equal to sine square theta over sine square theta all over cos square theta. So that sine square theta times cos square theta all over sine square theta. This will cancel out this. The final answer will be cos squared theta. All right, so there is what we call spatial angle. Spatial angle. What do you mean by spatial angle? We have 30 degree, we have 45 degree, we have 60 degree, we have 90 degree, 120 degree, etc. Now, when we have these, we can actually get sine 30, the answer, sharp, sharp. How? Cos 30 and we can also have sine 60, cos 60. So how will this work? Look at it. When you have something like this, we call it equilateral triangle. Here, 60 degree. Here, 60 degree. Here, 60 degree. This is equilateral triangle. And we take the sides to be 2, 2, 2. So that if you divide it into 2, here will be labeled M. And from here to here, 30. And here will be 30. So whatever that is adjacent, 60, but adjacent, 30. Opposite to 30, adjacent. So If this is opposite, 1 is opposite to 30, this side is adjacent to 30. If x is opposite to 60, 1 is adjacent to 60. Take note of it. So how do we find x? By applying Pythagoras theorem. By applying Pythagoras theorem. So we can quickly say opposite is x. Okay? Hypotenuse is 2. Adjacent is 1. Or we quickly say Pythagoras theorem, hypotenuse squared is equal to x squared plus 1 squared. Okay? So that 2 squared is 4 equal to x squared plus 1. We make x the subject of formula by saying x squared is equal to 4 minus 1. Okay? Now 4 minus 1 is what? X squared is equal to 3. Then x is equal to square root of 3. Alright, so x is square root of 3. So we remove x and put it square root of what? 3. It is from here we can now say that sine 30, we are considering 30 now. As you are considering 30, we are looking at this 30 or this 30. As you are looking at this 30, the opposite side is 1. Adjacent is root 3 over hypotenuse. So opposite to 30 is 1. Hypotenuse is 2. So we write opposite over hypotenuse. Opposite over hypotenuse. Have you seen that sine 30 is 1 over 2? Okay. Cos 30, therefore, we give us what? Cos 30 is adjacent over hypotenuse. As we are considering 30, adjacent is here, opposite is here. So adjacent over hypotenuse. So root 3 all over 2. Have you seen that cos 30 is root 3 over 2? So this is how you get it. Now, let's consider sine 60. Sine 60, therefore, we are considering this. And opposite is now root 3. So for sine 60 is equal to opposite is root 3 over hypotenuse 2. And cos 60 is equal to adjacent is 1, hypotenuse is 2. 1 over 2. And that brings us to the solution. That brings us to the solution to sine 30 cos 30, sine 60 cos 60. So go through it, you will understand. This is an equilateral triangle, equal sides and equal angle. So you divide it into 2. This left-hand side is equal to right-hand side. Keep on liking, okay? Keep on liking. All right. As long as we are talking about spatial angles, we use these spatial triangles. Spatial triangle is isosceles triangle. Spatial triangle is equilateral triangle. All right, so using another one called isosceles triangle, where here and here, we call here 1, 1, but they have the same base, okay? The base angles are equal. So here is 90, and here, therefore, is 45, 45. So we call this side x. Here is 1, 1. So what do we do? Applying Pythagoras theorem, x squared is equal to 1 squared plus 1 squared. Okay, from here, you will now find out that x squared is equal to 1 plus 1. X squared is equal to 2, which implies that x is equal to square root of 2. So you have that here is square root of 2. Now, we can consider again sine 45 cos 45. This time around, tan 45. All right. Do you know that sine 45 is equal to, considering any of these sides, this is opposite to 1, 1 is opposite to 45, so they both can serve as opposite and adjacent at the same time. So here now is opposite over hypotenuse, so 1 over root 2. But take note, you don't leave it like this, 1 over root 2 like that. It's not possible. So you rationalize it. So you have root 2 over 2. So sine 45 is root 2 all over 2. Now, cos 45 is equal to, okay, 1 all over, adjacent over hypotenuse, 1 all over root 2, okay, which is the same thing as root 2 all over 2 when you rationalize. Now, tan 45 is equal to what? Opposite over adjacent, 1 all over 1, which is 1. So, tan sine 45 is root 2 over 2, cos 45 is root 2 over 2, and tan 45 is 1. So that is how we get them, sine 45, cos 45, and tan 45. Keep on liking, keep on liking, keep on liking. God bless you. As long as you're liking this, you're sharing it, understanding will be perfect and maximum. All right. Now, another part again is, okay, quadrant. This is first quadrant. You have theta. Second quadrant, 180 minus theta. Third quadrant, theta plus 180. Fourth quadrant, 360 minus theta. How did we come to get all of this? Now pay attention. Pay attention. When we talk about quadrant, yes, let's say angle theta, there is theta, okay, and we have another one here. There is 180 minus theta. We have another one here. There is theta plus 180. We have another one here. There is 360 minus theta. So the angle which the line makes with the radius makes with the horizontal line, the angle which the radius makes with the horizontal line is considered. So we are taking this as theta. Can you see it here? As the first quadrant. We are taking this 180 minus theta as second quadrant. There is an angle here. That does not mean that we don't have angle here. But this angle here, we don't consider it because it's the angle that the radius is making with the vertical line. We don't consider that. There is also an angle here. We don't consider it. We also have an angle here. We don't consider it. We also have an angle here. We don't consider it. So the angles we don't consider are the angles that this radius makes with the horizontal, with the vertical. The one we consider is the one that it makes with the horizontal. Have you seen it? That you can see theta, 180 minus theta, theta plus 180, and 360 minus theta. But in secondary school, they told you 180 minus theta. But here, do you know that what you have here now? Here, look at it, look up, so that you understand. Do you know what you have here is 90 minus theta? Do you know what you have here is theta plus 90? Do you know what you have here is 270 minus theta? Do you know what you have here is theta plus 270? Okay, but you don't need it because these are angles that are making, you are making angle reduce with vertical. So the one that is made with vertical is not needed. The ones that are needed is the angle the radius makes with the horizontal is taken. The one this one makes with the horizontal is taken. So in case you are asked, how come we do not use 270 minus theta in third quadrant? Take note of this. This is the reason. 270 minus theta is there. But the reason why we don't take it is because R is making angle with the vertical. It's not supposed to be with the vertical, but with the what? Horizontal. The same thing, this one is with the horizontal, vertical. Can't you see we took this one because it's with the horizontal? We took this one horizontal, horizontal, horizontal. So that is why we took the ones that the angle made with the horizontal. Now, the next point is this. The next point is this. We have all, let's call x here, y here, minus x and y. And we've already known that this is R. This forms y and x. Okay, now, why is this place positive? Okay, sine theta is equal to opposite all over what? R, hypotenuse. So y over R. Is it positive or negative? Positive. Cos theta is equal to x over R. Positive or negative? Positive. Then tan theta is equal to opposite over adjacent, y over x. Now, we go here, pay attention. None of this, sine theta, cos theta, tan theta, is negative. Hence, we say all positive. All positive. Here, y is positive, but x is what? Negative. That means sine theta is equal to y over r. Positive. So sine is positive here. That is why we say that sine is positive in second quadrant. So sine theta is positive in second quadrant. Again, cos theta is equal to minus x, have you seen it? Over r. So minus x over r. Okay? Minus x over r. Minus x over r. So cos theta is minus x over r. What does that mean? It means that here is negative and cos is negative in second quadrant. Let's check tan. Tan theta is equal to y over minus x. Y over minus x is negative. Cos is negative. Sine is positive. So only sine is positive. Only sine is positive. Only sine is positive. In second quadrant, only sine is positive. In first quadrant, all positive. Now let's check out the third quadrant. In the third quadrant, we have negative y and negative x reduced. Okay, this is second quadrant. Now, in third quadrant, sine theta is equal to minus opposite over hypotenuse minus y over r minus y over r. You see, sine is now negative in third quadrant. Sine is negative in third quadrant. Minus y over r, opposite over hypotenuse. Now, cos theta is equal to minus x over r. Have you seen? So minus x over r. Cos is negative. Now let's see. Let's see. For tan theta is equal to opposite over adjacent over minus y over minus x minus y over minus x, and this will cancel out this. So tan is positive. So only tan is positive. Only tan is positive. Have you seen it? Only tan is positive. Only tan is positive. All right. So what happened in the fourth quadrant? In the fourth quadrant, you notice that here is our negative y, but s is positive. Fourth quadrant, sine theta is equal to opposite. Since here is theta, here is theta, here is theta, we are considering opposite over x. Here is r. Opposite over r. So minus y all over r minus y all over r. So sine is also negative in fourth quadrant. Cos theta is equal to x, well, s over r positive, then tan theta is minus y over x negative. So in fourth quadrant, we have tan cos theta positive and theta positive, positive, sin theta positive, then here all positive. Okay, so that is how we say it. Okay, so we have this as our quadrant. I have explained everything about the quadrant. Okay, I've explained everything about the quadrant. All right. Now, when you are given sine 150, sine 150 equal to cos 2x, what will you do? Question says find x. So if you are given such question, you will notice that 150 here is in which quadrant? 150 is in second quadrant. Have you seen it? So when they give you something like you first of all check it, is it in first quadrant? So since 150 is in second quadrant, okay, in second quadrant we have that 180 minus 150 is equal to what? 30. So this is the real angle that you are supposed to be saying. So that sine 30 is equal to 1 all over 2. Have you seen it? And you check again, because this sine 150 is in second quadrant, we already know that sine is positive. So 1 over 2 must be positive. 1 over 2 must be positive. So 2x is equal to 1 over 2, positive 1 over 2. Therefore, 2x is equal to cos inverse of 1 over 2. We have already known that cos inverse of 1 over 2 is 60, because cos 60 is equal to 1 over 2. So cos inverse of 1 over 2 is 60. So from here, 2x is equal to 60. You now divide both sides by 2. 60 divided by 2 will give us 30. So x is equal to 30. X is equal to 30. Now, do you know that cos 240 is equal to what? First of all, when we have 240, you already know that 240 is in third quadrant. 240, just pick the angle alone. When you pick the angle, you already know 240 is in third quadrant. Now, consider 240 to be in third quadrant. Say 240 is in third quadrant. If it's in third quadrant, tell me, in third quadrant, is cos positive or negative? Cos, is it positive or negative in third quadrant? Are you getting it now? So when you are able to identify that the cos is positive or negative in third quadrant, we can move ahead. So what should we do? You now find out that 240 is in the third quadrant, 240, third quadrant. Now, we now say, in third quadrant, theta plus 180 is the angle that is there. Are you getting the point now? But we need what theta is to go ahead. And cos is positive. Is Cos is negative in third quadrant. Cos All right, I hope you can hear me now. Okay. Okay, so what I'm trying to say is, if you are asked to find cos 240 degree, all you need to do is look at 240 will direct you to the quadrant it is. So 240 is in third quadrant. Cos, is it positive or negative in third quadrant? It is negative. Okay, so if cos is negative in third quadrant and 240 is already an angle that is present in third quadrant, what is the general angle in third quadrant? Theta plus 180. So theta plus 180 is equal to 240. Have you seen it now? So theta is equal to 240 minus 180 to help us get 60 degree. Now, this 60 degree is special angle because we always like to get this theta because this theta is always the angle in the first quadrant. 60 is in first quadrant. So now, cos 240 is equal to minus cos 60 degree. Have you seen it? So minus cos 60 is the same thing as cos 240. So our answer therefore is minus cos 60 is what? 1 all over 2. If you punch your calculator, you get minus 1 all over 2. But this is exactly how it means, how you solve it, how you go about it. Okay, let's look at this. Let's say cos 330 degree is what? So if you are asked to find cos 330 degree, what will you do? We already know that 330 is in fourth quadrant and cos is positive in fourth quadrant. So our answer now will be 360 minus theta is equal to 330. Okay. No, cos is positive in fourth quadrant. Cos is positive. Cos is positive in fourth quadrant. Cos is positive in fourth quadrant. Fourth. Okay. Not negative. Cos is positive in fourth quadrant. Take note of it. All right. So 360 minus 330 equal to theta. So 360 minus 330. What will you get? 360 minus 330. What will you get? Theta is equal to 30 degree. So cos 330 is the same thing as plus cos 30 degree. And you already know what 30 degree is. Root 3 all over 2. So cos 330 is equal to cos 30 degree, which is square root of 3 over 2. All right. Okay. We have what we call sine A plus B cos A plus B sine A minus B cos A minus B and A plus B and A minus B. All right. So we go again. Addition of sum of two angles. Sum of two angles. Okay. Sum of two angle formula. All right. Addition or subtraction of two angles. All right. So this is the same thing as sine A cos A plus cos A sine. Okay. Then here tan A plus tan B all over 1 minus tan A and B. Okay. Okay. So this is the major thing we need to learn today. Addition of two angles formula. Sine A plus B is equal to sine A cos B plus cos A sine B. Okay. All right. So here we have sine A plus B, sine A cos A equals B plus cos A sine B. Here we have cos A plus B equals cos A cos B plus sine A sine B. Here we have sine A minus B, sine A cos A minus cos A. If you notice, this cos alternates, changes, but sine remains the same, plus plus, minus minus, but cos plus minus, then minus here will be plus, for the same cos A cos B, sine A sine B. All right. That's what I'm just saying now. That your question. If I chuku, cos alternate. If it is plus, then it will be minus. If it is minus, it will be plus. Take note of it. Okay. Then for tan A plus B, you see, tan A minus tan B, 1 over 1 plus tan A tan B. Then tan A minus B is tan A plus tan B over 1 minus tan A times B. So pay attention to this. We are going to utilize it. All right. We have double angle formula. Okay. From the addition formula, we have double angle formula. Keep on liking the video, okay? Keep on liking it. Like and share, okay? Appreciate this work by liking what I am doing. Share it to the various groups so that they can join and see what we're doing. This was how all your quiz questions came from the physics and chemistry that I dropped here. Okay? So keep on sharing, keep on liking, impact knowledge. Impact. We impact knowledge. No matter what. Keep on liking, keep on sharing, okay? Keep on liking, keep on sharing. Okay? You are welcome. Now, when we talk about double angle formula, we go back again. Remember our double angle formula, meaning that A times A, double, 2 of A, double angle, 2 of A, double, okay? So when we have 2A, you know what that means? Sine 2A, it means that anywhere we repeat the same thing, sine A cos A plus cos A sine A. Have you seen it? Double angle formula. This is just like that one we did, A plus B, where A is equal to B. We now have 2A. A plus A is 2A. So, sine 2A is equal to 2 sine A cos A. Do you remember this? Okay, let me put it down closer. If A is x, sine 2x is equal to what? 2 sine x cos x. You can now know where this is coming from. Beautiful. Thank God for your life. You have seen it. Now, cos 2A will give us cos A minus sine A sine A. Because plus will give us minus. Yeah. Okay. Y plus will give us plus here for sine. Y for cos, it will change, it alternates. So cos 2A is equal to cos A times cos A is cos squared A minus sine A times sine A sine squared A. So this is very, very important. Cos 2A is, so imagine we have cos, let A be S, cos 2S is equal to cos squared X minus sine squared X. Have you seen it? You remember this? Take note of it. Also, tan 2A is equal to tan A plus tan A. Okay? Over 1 minus tan A tan A. Okay? So we have tan 2. All right. Double angle formula. double angle formula. All right, evaluate cos squared 15 minus sin squared 15 is equal to what? So I will grab my teeth. So the first thing you do is look at it very well. Compare with cos squared A minus sin squared A is equal to cos 2A, okay, from double angle formula. So that cos squared 15 minus sin squared 15 is equal to cos 2 times 15. So cos 30 is equal to root 3 all over 2. That is the answer. So if you are asked to evaluate this, what will you get? Recall sin A cos B minus cos A sin B is equal to sin A minus B. Because for sine, we have minus, minus. For cos, we have minus, plus. So, comparing them, you have sine 75 cos 15 minus cos 75 sine 15 is equal to sine 75 minus 15. So 75 minus 15 is 60, which is the same thing as sine 60. And sine 60 is the same thing as square root of 3 all over 2. It's trigo identity, not cosine rule. All right. All right. Let's look at tan 30 tan 60. All you just need to do, recall, we have root 3 here, 1 here, 2 here. So here is 30, here is 60, here is 90. So, opposite over adjacent, opposite over adjacent. So if we are considering 30, opposite over adjacent over root 3, which you rationalize to give you root 3 all over 3. Okay, so 60, 60, opposite over adjacent. Root 3 all over 1, which is 3. Simple and short. So if you want to get tan 30, tan 60, you do this and you get the answer correctly. Okay. Now, anytime you are given any sine of any angle, for example, you are given sine 120 degree is equal to what? 120 is in second quadrant. And if 120 is in second quadrant, sine is positive in second quadrant. So your answer must be positive. Sine 180 minus 60. So 180 minus 60 will give us 120. So theta is equal to 60. Therefore, sine 120 is equal to sine 60. So this is the same thing as this, which is the same thing as root 3 all over 2. So when you punch sine 120 in calculator, you get 3 all over 2. Nothing else again. Trigonometry 2. Okay, let me show you partial differentiation. Partial differential equation. F of xy is equal to x cubed y plus y cubed minus x squared y minus 5. So when you are given this question and you are asked to find f prime of x comma y, what will you do? First, you differentiate f with respect to x. Okay? Keep it here. Differentiate f again with respect to y. Keep it here. This is your answer. So as you are differentiating f with respect to x, we keep y constant. Y is constant here, and s is constant here. So let's go. The x is equal to what? We are differentiating with respect to x. So x alone is here. There is y, but we pretend as if y does not exist. Y is constant. So differentiating x cubed, you have 3x squared, then y is constant. Don't touch it. Differentiate x. There is no x here, so 0 is gone. Differentiate minus x squared. You have minus 2x, and y squared is there. It differentiate 5, you get 0. So you're done with this. Now, the f respect to y. This is not ordinary differential equation. This is called partial differential equation, and it is pronounced as del f. Delta f. Okay, partial derivatives. Delta f. Okay, and now if you differentiate with respect to y, you keep s constant. So differentiate y, what will you get? 1. 1 times s cubed, you have s cubed. Right, s cubed. Plus, if you differentiate y, you have 3y squared. Finish. If you differentiate y squared here, you have 2y. So minus 2x squared y. If you differentiate minus 5, you get 0. So your f prime of x comma y, however, is 3x squared y minus 2xy squared, comma, you have x cubed plus 3y squared minus 2x squared y. So if you compare this with the quiz you did, this is how you are supposed to present your solution. Okay? This is how you're supposed to present a solution. Now, let me show you what we call implicit differentiation. So when we talk about implicit differentiation, we have x cubed y plus y cubed minus 2x squared y squared equal to 5. This is implicit differentiation. Find dy dx not delta y delta x. dy dx is ordinary differential equation. They say find dy dx, ordinary differential equation. Okay, so how do we go about that? This is product rule. We apply product rule. Keep y constant, differentiate s cube. Keep s constant, differentiate y. So we have s cube. Let's add the shortcut first. Dy dx is equal to, then s cube is not supposed to be here, but when you differentiate it, you have 3s squared y. You have negative, put it at the numerator, but negative 3x squared y. Now, keeping s cube constant, differentiate y is supposed to be here. You have plus s cube. Now we go to this, y is supposed to be here, differentiate it, keep it at the denominator. Okay, plus 3y squared minus 2x squared y squared. You're differentiating 2x, keeping y constant. This minus 2x is not supposed to be here, but you change it to plus. So you keep it at the numerator plus. Differentiate 2x, we have 4x y squared. So we have 4x y squared. Differentiate 5, there's 0, it goes. Now, that is all. That is all. We now differentiate y squared, keeping 2x squared constant. All right. And this y squared is supposed to be here. So we retain the minus, right? Minus, differentiate y squared, have 2y, that is 4, okay, x squared y. 4x squared y. All right. So this is the solution to this question, dy ds, the implicit differentiation, the shortcut. So this one is shortcut. Okay, shortcut by Blendo. Shortcut by Blendo. So that is how we talk about implicit differentiation. All right. So we can quickly do this one. Okay. Now we're through with implicit differentiation. Let's talk about integration. Integration is the reverse process of finding the what? The derivative of a function. The reverse process of differentiation is integration. So this is called the integral sign, okay, which is also called y. When you have dy ds given the slope as or gradient or tangent, you are asked to find y, because this is dy ds given, you must find y. And by finding y, you now have to integrate it. Okay. We have methods of integration, but our aim today is to integrate 3x, x plus 3, x minus 2, applying integration by partial fraction. We are using integration by partial fraction shortcut on integration by partial fraction. Integration by partial fraction shortcut. If you are ready for the shortcut, say I am ready. Shortcut on integration by partial fraction. Until I see I am ready, I want to solve this. So say I am ready for the shortcut, we move. Keep on sharing. Say I am ready for the shortcut. If not, no shortcut for you. I am ready for the shortcut, we move. Jessica, you are the one in number 1 and you have sustained your number 1 for a long time. So Jessica Nweze, you can kindly drop your account details in my WhatsApp and type you are Jessica. Jessica Nweze. Jessica Nweze, you have sustained number one for a long time. So type your account number in my WhatsApp and drop it as Jessica Nweze. Jessica Nweze, you have been on number one. Type it on my WhatsApp. Okay, you have been on number one. Type it on my WhatsApp. Say, I am the Jessica Nweze. Okay. All right. So, all right. So, you say, I'm ready for the shortcut. We move. Okay. You say, I'm ready for the shortcut. We move because I'm going to solve it integration by partial fraction. Integration by partial fraction. Integration by partial fraction. I'm going to show you how to do that. Share this, like, keep on liking, keep on liking, keep on liking. Okay, keep on liking. Let's go. All right. Okay. Y is equal to, very simple, in x plus 3, x plus 3 plus in x minus 2, hello, plus c. Here is A and here is B. Now, next step, pick x plus 3 and say x is equal to minus 3. So when x is equal to minus 3, we are looking for A. Because minus 3, x plus 3 equal to 0, x is equal to minus 3. We are looking for A. Then come over here. Put x equal to minus 3 in all of this except x plus 3. So 3 times minus 3 minus 9 over minus 3 minus 2 will give us minus 5. This cancel this. We have 9 over 5. Correct. So come here, x minus 2, when x is 2. So when x is 2, we are looking for B. So put 2 in all except x minus 2. So 3 times 2, 6. 3 plus 2, 5. That is your final solution. You now write therefore y is equal to 9 over 5 in x plus 3, oh my god, plus 6 over 5 in x minus 2, oh my god, plus c, oh god, that is the final solution. That is the final solution. That is the final solution. Wow, very beautiful. I love this shortcut. I know you love it. If you love it, say I love it. And you love this shortcut. It's too short. I love it. The shortcut is so shortened, so beautiful, so beautiful. I love it. Beautiful. All right, let's keep on with another question on integration by partial fraction. Integration Okay, let's integrate 5x all over x squared 3x minus 4. Okay, let's integrate. Yeah, Oyibe, Oyibe, I can see you. You know, get wahala now. I hope you are following. That is just the major thing. Ikechukwu Joshua, I dey test you. You are welcome. All right, let's hit to this shortcut again. But before you know that, this is x squared plus 3x minus 4. You need to factorize this, okay, so that it will make sense. We need these values. So what will you do? Put x here, split 4 into 2, so that we have 1 and 4. So 1 times 4, 4. 1 minus 4 plus, no, you know where. So here is 4 minus 1. 4 minus 1 is plus 3. 4 times minus 1 minus 4. So you put minus 1 here, you put plus 4 here. We are done with the factorization. So therefore, y, applying the shortcut, a in x minus 1 plus b in x plus 4 plus c. I know you love it. Now, a, we now say x equal to 1 because x minus 1 is for a. We are looking for a. So carry this one, put it around there except x minus 1 and say 5 times 1, 5. 1 plus 4, 5. This cancel this, you get 5. A is equal to 5. Now, x plus 4 is equal to x minus 4. Okay, we are looking for b. So anywhere you see x, put minus 4. So 5 times minus 4, we have minus 20. Then minus 4 minus 1, we have minus 5. So this cancel this. 20 divided by 5 will give us 4. I know you love it. Now watch this. We now say y therefore is equal to, what is a? 1. So you have in x minus 1, you put 1 at the back, plus what is b? 4. 4 in x plus 4 plus c. That is a beautiful answer to this question. I know you love it. So if you love it, say I love it. This is very short. Okay? The shortest ever in integration by partial fraction. You can go back to your notebook, try it. I know you love it. Still on integration, let's look at integration by parts. Integration by parts. When you are asked to integrate x squared in x dx, don't stress yourself. We are going to apply shortcuts. We are going to apply shortcut. We are going to apply shortcut. So what should we do? Very simple. And look at this. We have hierarchy of choosing our u. So u can be in x. If you say in x, like this in x and x squared, u is in x. You see? Then if you now say, you didn't say u in x, you must say xn. If you didn't say xn, you must say sine x, cos x, or ex. So the highest is in x, followed by xn. Then if you see Sn and sine, you choose Sn as your u. So this is the hierarchy of choosing u. But that is that for theory, but we're not talking about theory. We're talking about OBJ. Shortcut. How do we solve this? By mere looking at it. All right. Take note of this. Now look at this question. S squared in x. Integrate s squared. You see? Because we are already having that this is in x. Integrate s cubed. What will you get? S cubed all over 3. Yes, s cubed all over 3. So open bracket in x minus 1 over 3 plus c. What a beautiful answer. What a sweet answer. I know you love it. This is the shortcut. But if you don't understand, just hold on. This is the first one. I know you don't understand, but this is the first one. You are going to understand after several questions done. It's too short for you to understand, Desire. I said when you are given this x in x, we are here together. This is x. Integrate x. What will you get first? Integrate x. What will you get? X squared all over 2. You put in x minus 1 all over 2 plus c. I pray. Beautiful answer. I know you love it. You love it. Oh, yeah. I want you to say this again. I pray. Say you don't understand them again. Y is equal to integral x4 in x. Who can tell us how the answer looks like? Integral x4 in x. Integral x4 in x. So y is equal to integrate x raised to power 4. You have x raised to power 5 over 5. Okay, into bracket in x minus 1 over 5. Say, I love it. If you understood it, you say, I love it. Okay, I know you love it. Now, let's see. Keep on sharing, like, okay? Keep on liking it. Like it, like it, like it, like it. All right, I hope you can hear me. I hope you can hear me now. I hope it's clear. All right, let's look at another method under integration by part. When you are given integration of this kind, x3 e x dx, don't stress yourself. You are doing something beautiful. You say y is equal to, you write down x3 ex plus. Next is minus. Differentiate x cubed. What will you get? You will have 3x squared ex plus differentiate 3x squared. What will you get? You will have 6x ex plus minus differentiate 6x. What will you get? You have 6 ex. Differentiate 6. What will you get? You'll have 0 is gone. So you put C. So that is the answer. As simple as ABC. When you are given y is equal to integral x ex, integral s ex, what will you do? Same. Y is equal to write down ex minus differentiate x. What will you get? 1. So you write ex, then differentiate 1, you get 0. You write plus C. Very beautiful. Very, very beautiful. Are you following? Okay, let's look at this. When you have integral x sine x, all right, you have y is equal to, this is x is here. You write x, okay? When you write x, put it down, integrate sine x. You have minus sine x. You write minus cos x. So we have minus already here, but minus times minus is plus. If you integrate cos x, you have minus. We have sine x, but minus is already here. Minus is here, so you make it plus. So differentiate x, you have 1. So here is sine x plus c. Okay, let's try this. Integral x cos x dx. So you write down x, integrate cos x, you have sine x. Okay, normally we have minus here. Then differentiate x, we have 1. Integrate sine x. We have minus. Okay, minus times minus is what? Plus. You write plus cos x plus c. All right. Applying what we call DI method. If you have heard of DI method, let us see what it means. DI method. I hope you are following. I hope you're getting it. I hope you are following. I hope you're following. I hope you are following. Hope you are following. Hope you are following. Hope you are following. Mm. Keep on liking. Keep on liking. Okay. Keep on liking. All right. So let's look at this. Y integral x squared sine x dx. Let's use DI method. If you know DI method, say I know DI method. I know DI method. Okay? If you know DI method, you say I know DI method. If you don't know DI method, say I don't know DI method. DI method. So D is differentiation, I is integration. So for DI method, we are differentiating this part, integrating this part. You have x squared and you have what? Sine x. So here is plus minus plus minus. Now differentiate x squared, you have what? Differentiate x squared, you have 2x. Differentiate 2x, you have 2. Differentiate 2, you have 0. It's gone. Integrate sine x, you have minus cos x. Integrate cos x, you have minus sine x. Okay, and so on and so forth. Integrate sine x, you have loss cos x. All right, so this goes with this goes with this, and this stays with this. So that our final solution becomes y equals minus x squared cos x, because minus times plus is minus. Minus times minus is plus, plus 2x sine x, plus times plus is plus, plus 2 cos x, then plus c. That is your final solution. This is called DI method. Okay? It's called DI method. This is DI method. If you don't understand, say I don't understand. We run it again. Integration by parts. Mickey Mitch, you are welcome. I am saying if you are given integral x squared sine x, or let's use cos x this time around. Okay? X squared cos x dx. Now, we apply DI method. What do we mean by DI method? Differentiation, integration method. There is plus, there is minus, there is plus, there is minus. So D, the one that is U is S squared, then cos X is for integration. So you differentiate S squared, you get 2x, integrate cos S, you get sine X, differentiate 2x, you get 2, integrate sine X, you get minus cos X, differentiate 2, you get 0, integrate cos S, you get sine S, retain minus. All right. So you move from up, down, up, down, up, down. So plus times plus, plus is here, plus times plus is plus. So our final answer becomes x squared sine x, x squared times sine x. You write it down. Then 2x cos x, but minus times minus is plus. 2x cos x. Yeah, plus times minus is minus. So minus 2 sine x. 2 sine x plus c. So this is the final solution. And apply this to the previous one I just solved to give you the same answer. Like the same pattern of answer, not the same answer, but the same pattern. Integral cos x e sine x dx. Shortcut. Differentiate sine x. What will you get? Cos s. So you write cos x e sine x over cos x, okay, plus c. Can this cancel this? Yes. So y is equal to e sine x plus c. All right, so let's look at some questions. All right. All right. What's the answer to this question? All right. So looking at the question, how do we address it and solve it? Does it look difficult? Does it look simple? Who can attempt it? All right. I hope you're following. Are you there? Recall that sine squared x plus cos squared x is 1. In E is 1. However, y is equal to integral in E1 dx. This means in E is 1 dx. Integrate 1, y will give us x plus c. That is the answer. Integrate in x dx. Answer. Here is 1. If you integrate 1, you get x. In x, in x minus 1 plus c. All right. All right. If you're asked to integrate this, all you need to do is look at the lower limit and upper limit. They are the same. The answer is 0. As long as the lower limit and upper limit are the same, the answer is 0. Differentiate an x, you have x squared x, x squared x. Let's cancel this. All right, so what we do in this question, differentiate x cubed, we have, write this down. Differentiate x cubed, we have 3x squared plus c. Let's cancel out this. Y is equal to ax cubed over 3 plus c. All right, so y is equal to integral when you're asked to integrate this, write everything out. Add 1 to 4, differentiate x squared, you have 2x, add plus c. This can cancel out this. 2 times 5 is 10, x squared plus 5 raised to the power 5 over 10 plus c. All right, so let's see how we can integrate this. X squared, okay? Now, if you integrate sine x, you will get minus cos s. If you differentiate 5s cubed, you will get 15s squared. So you have 15s squared. Differentiate 4, you get 0 plus c. So what should we do? This, we cancel out this. Y will be minus cos 5s cubed plus 4 over 15 plus c. All right. When you are given integral of the answer is integrate sine x, you get minus cos x plus 4. Differentiate x, you get 1 all over 1 plus c. So your answer is minus cos x plus 4 plus c. Keep on liking the video, share the video, share the video. All right. On liking the video. If you are given something like this to integrate, what will you do? First of all, you have in x minus 3. Okay. And 5 is at the back. Plus c. All right, I would like you to solve this. Then I will do the correction immediately. Solve this and drop the answer in the comment section. Solve it and drop the answer in the comment section. Chop queen, you have sustained number one position. You have sustained for a long time, number one position, chop queen. You can chat me up on WhatsApp, drop your account details, chop queen. Chop queen, you have sustained number one position. You can chat me up on WhatsApp and put your chop queen, put chop queen that you are the one that is chop queen. I will see your name, I will see your number. All right, let's solve them. Number one, the answer is xex minus, differentiate x, you get 1, the ex plus c. This is equal to x3 all over 3 into in x minus 1 over 3 plus c. Very simple. This is minus x cos x minus times minus is plus sine x plus c. This is x3 plus 4 raised to power 6 all over 3 times 6 plus c, where 3 times 6 is 18. So that is the answer to the 4 question. 3 times 6 is 18. Solving question in less than 1 minute is amazing. Learn this properly and be happy. If you love it, say, I love it. I love it. It's an amazing work. It's an amazing work. Keep on liking. Mirabel, you are welcome. Can you be specific? The one you don't understand, can you be specific? Be fast. Tell me the one you don't understand. Mirabel. Chop Queen, I hope you have chatted me up on WhatsApp. You have sustained your number one position. Mirabel, are you just coming in? Are you just joining us, Mirabel? Okay. Okay, you are welcome, my dear. Mirabel, keep on joining the live videos. You will really enjoy it and you do very well. Keep on joining the live video. You do very well. Okay? When I'm done with this video, I will still drop it again. You see it from beginning to the end. All right. You said you do not understand the second one. Um, the second question says that y is equal to x squared in x dx. Oh, Mirabel, thank you so much. Go through the videos that we've done previously. You shall understand and love them. Okay? To really help you for your exams. To really help you for your exams. Trust me. Okay? Now, if you have y is equal to integral x squared in x dx, all you need to do is x cubed over 3 in x minus 1 over 3 plus c. This is a shortcut method. This is a shortcut method. Okay? Now, y, if you integrate x3 in x, what will you do? Integrate x3, have x4 over 4 into in x minus 1 over 4. Okay? Into plus c. Oh yeah, Mirabel, look at the second one I did. We have x2, we integrate it to x3 over 3. We have x3, we integrate it to x4 over 4. Okay? How we got x3 is this. If you are asked to integrate x squared, it is x squared plus 1 over 2 plus 1. This is how to integrate. Thank you so much. I so much like that. Thank you so much. You're welcome, Mirabel. Thank you so much. I'm happy for you. I'm happy for you. Thank you so, so much. Any question you have, ask me. You shall get the solution, okay? Thank you so much. You are welcome, Mirabel. All right. Now let's look at a question on this integration. A situation where you have y integral um, sec squared x dx. If you are asked to integrate sec squared x dx, what would you do? Sec squared x dx. What would you do? Remember, the answer is tan x plus c. Tan s plus c. If you differentiate tan x, you get sec squared x. If you integrate sec squared x, you get tan x. Simple and short. They are reverse process. When you have y is equal to integral 1 all over 1 plus x squared. If you integrate this, you have tan inverse of x plus c. If you differentiate tan inverse of x, you get 1 over 1 plus x squared. If you integrate it, you get this is a reverse process. Things you don't need to struggle yourself, you don't need to stress yourself on. We have a situation whereby you have x into x squared minus 5 raised to power 4. This is integration by substitution method. So how do we go about that? If you are asked to find this, what will you do? You write down x squared minus 5, then add 1 to 4, it becomes 5 all over 5, multiply by, differentiate x squared, you have 2x plus c. So this x cancel out, as 2 times 5 is 10. So your final answer is x squared minus 5 raised to the power 5 over 10 plus c. Thank you so much, Mirabel. Keep on liking the video. Keep on sharing. All right. Let's see a question under integration by partial fraction. We have x plus 3 over x squared minus 25. So how do we solve this? We solve it by first factorizing the denominator. Okay? You have x plus 3 all over. Here, we have difference of 2 squared, because square root of 25 is 5. So we have x minus 5, x plus 5. That is all. We say a in s minus 5 plus b in x plus 5 plus c. So, I know you must love this. You love it. X minus 5, x plus 5. So when we take x minus 5, that means x is equal to 5. We can get a. So anywhere you see x, put 5, except x minus 5. Don't add it here. So 5 plus 3 will give us 8. 5 plus 5 will give us 10. Then secondly, x is equal to x plus 5. We're looking for b. So we have x is equal to minus 5. So b therefore becomes minus 5 plus 3. That is 3 minus 5 minus 2 over minus 5 minus 5 minus 10. So this cancels out this. Our final solution is a is 8 over 10. If you reduce it, we have 2 here, 4, 2 here, 5. So it will become 4 over 5 in x minus 5. Then here, 2 here, 1, 2 here, 5. It will be plus 1 over 5 in x plus 5. So plus c. So this is your final solution. Okay? So when you have this type of question, you get your answer like this without stress. Without stress. This is shortcut by Blendo. Okay? Keep on liking the video. Like, share, watch it to the end, stay to the end. You will love it. Okay? Keep on liking the video. Thank you so much. Okay, tell me if you can hear me. If you can hear me, you let me know. Okay, Chuku Elom, you are welcome. Let's welcome our brother from Ghana. Elom Okechukwu, you are welcome. Okay, we are still dealing with integration. Elom Okechukwu, you are welcome from Ghana. We are still dealing with integration. Okay, so y is equal to integral. Y equal to integral x raised to the power 2 sine x. This is integration by part. So we are going to use the method called DI method to solve this. We are going to use DI method to solve this, okay? Now, here we put plus, here we put minus, plus, minus. Okay. Whenever you have x squared and sine x, pick x squared as for your differentiation part. So you put x squared here, sine x, you put sine x here, okay? Then differentiating x squared, you will have 2x. Integrating sine x, you will have minus cos x. Differentiating 2x, you will have 2. Integrating cos x, you will have sine x. We bring this minus down. Then differentiate 2, we have 0. Integrate this, we have cos x. Minus times minus plus, so I have plus cos x. All right. This go down, this go down, this go down. So you write y is equal to minus times plus is minus x squared cos x. Minus times minus is plus 2x sine x plus 2 cos x plus c. Okay, so that is the final solution. That is how you solve it. All right, let's see how we can solve a similar question in case you're asked. To solve y is equal to integral x squared cos x. Integration by part. Integration by part. Integration by part. How do we address it? You can leave your answer in the comment section. Keep your answer in the comment section. Keep your answer in the comment section. Integration by part. Integration by part. Keep your answer in the comment section. So what did you get? Try solving it. Okay, so we apply DI method also. And I say DI method. When you see x squared and cos, whether sine, cos, or anyone, just use x squared, put it in D already. So here is x squared and here is cos x, okay? Then here is plus, minus, and so on and so forth. So differentiate x squared, what will you get? You have 2x. Differentiate 2x, what will you get? You have 2. Differentiate 2, you have 0, you stop. Integrate cos x, what will you get? Sine x. Okay? Integrate sine x, what will you get? Minus cos x. And integrate cos x, what will you get? Minus sine x. All right, so this go down, go down, go down. That's your answer. I hope it's clearer now. So you now have y is equal to plus x squared sine x minus times minus is plus. So 2x cos x minus times plus is minus, minus 2 sine x plus c. So check your answer. If you got the same answer with me, type, yeah, I got the same answer. I'm right. Just say, I love it. If you have the same answer with me, say, I love it. I know you love it. Okay? I know you love it. The shortcut is shorten. All right. So let's see how we can give another method, because we are talking about the three basic types of integration. Three basic types of integration. We have methods of integration, integration by substitution, integration by parts, integration by partial fraction. So these are the basic methods of solving integration. So we're going to handle them one after the other. Today, we shall dissolve everything that is called methods of integration. Now, we have integrate 5x plus 3 over x squared minus 9. 5x plus 3 over x squared minus 9 dx. This is integration by partial fraction. So what will you do when you see a question like this? The first thing you do is you factorize the denominator. So how do we factorize the denominator? We use what we call difference of 2 squared. When you have x squared minus, this is 3 squared, so this is called difference of 2 squared. You create this, okay, and say x is here, x is here. So here is x minus 3, there is x plus 3. Beautiful. So what we do now is we have our a in first bracket, x minus 3, plus b in x plus 3, second bracket, plus c. So this is the structure of our solution. So how do we now get the final solution? We come over here and say, for a, we say x minus 3 equal to 0. So x is equal to 3 for a equal to. Now pick 3, put it in every part of this except x minus 3. So we say 5 times 3, 15. 15 plus 3, 18. So we write 18 over 3 plus 3, 6 over 6. 18 divided by 6, 3. You keep it for a. Now, we go to this x plus 3. That means x is equal to minus 3 for x plus 3 to be 0. Now, put this x minus 3 in all of this except x plus 3. So therefore, 5 times 3, 15. Or we say minus 15. 5 times minus 3 is minus 15. So minus 15 plus 3 will give us 3 minus 15, which is minus 12. So our b is equal to minus 12. Now, minus 3 will give us minus 6. So minus, we cancel out minus. 12 divided by 6, and 12 divided by 6 will give us 2. So that if A is 3, B is 2. So we now write our final solution as A is 3, 3 in x minus 3 plus 2 in x plus 3 plus c. So This is the final solution for this question. If you love this video, you love this solution, you love this shortcut, say, I love it. You say, I love it. Okay? For more solutions, for more shortcuts. Okay? You keep on loving it. I keep on giving you shortcuts. All right. Ask a question. If you have any question, you ask. If you have any question, you ask. Feel free to ask your question. Why? Okay. You integrate x raised to the power 5 in x dx. So when you have this, what will you do? Okay. What will you do? When you have it fixed, all right. So what will you do? This is x raised to the power 5. This is in x dx. Beautiful question. If it is cubic, okay, you're going to have three brackets. Okay, I'm going to do an example of that. I'm going to do an example of that question. If it is cubic, I'll show you how you go about it. Okay, let's solve this first. So x raised to the power 5 in x dx. So we have y is equal to, if you integrate x raised to the power 5, you have what? X6 over 6 into in x minus 1 all over 6 plus c. That is the answer. Finish. Okay? That is the answer. Let's say if you have something like this, x3 in x dx, your answer is what? x4 over 4, okay, in x minus 1 all over 4 plus c. That is the answer. Just remember, you're going to integrate x3 to get x4. Integrate x5 to get x6. All right. A situation you have y is equal to 3x over x minus 1, x minus 2, and probably x plus 4. Okay? This is x times x times x, x raised to the power 3. Very simple. All you need to do is y is equal to what? A in x minus 1 plus b in x minus 2 plus c in x plus 4 plus c. So that for x minus 1, we have x equal to 1, then a is what? Put 1 in all except x minus 1. So therefore, 3 times 1 is 3 at the numerator. Now, 1 minus 2 minus 1. 1 plus 4, 5. 5 times minus 1 minus 5. Have you seen it? I've gotten A. Then I will go for B. B is x minus 2. So x equal to 2. So now here is x equal to 2 for B. I will now say B is equal to what? Numerator 3 times 2 is 6. Over. Now 2, 2, 2. Don't put it here, or put it here and here. So 2 minus 1 is 1. 2 plus 4 is 6. 6 times 1, 6. You write 6. Have you seen that 6 cancel 6 will give us 1? Are you following? Now, when x is equal to minus 4, because if here is plus, whatever you get is minus. If here is minus, whatever you get is plus. So x is equal to minus 4. Take this minus 4, put it everywhere. This is for cubic denominator. Cubic denominator, okay? This is cubic denominator, so pay attention. So now x is equal to minus 4. You now see 3 times minus 4. You have c is equal to minus 12 over, now, minus 4 should not come here, but you put it here and here. So minus 4 minus 1 will give us minus 5. Have you seen it? Then minus 4 minus 2 will give us minus 6. So minus 4 minus 2 minus 6 minus 1 minus 5. So minus times minus is plus. Okay? So this will cancel this. 5 times 6 is 30. So 12 over 30. 2 here, 6. 2 here, 15. Do you understand? Then 3 here can give you 2. 3 here, 5. So our C can be reduced to 2 over 5. Do you know that we will now say y, this is going to be our final answer, is equal to, y is equal to, this is 3 over minus 5. So you have minus 3 over 5 in x minus 1. Okay. Then what is b? b is 1. So you have plus in x minus 2. Okay. So what is c? You have plus 2 all over 5 in x plus 4. Okay. So plus what? C. So this is the final answer. If it is for cubic polynomials, denominator cubic. Thank you, Okechukwu Elum from Ghana. Thank you for subscribing to the channel. Keep on following up. Keep on following up. Thank you so much. Thank you so much. I so much appreciate. Keep on following up the video. It's every day by 7 a.m. Every day, every morning by 7 a.m. Different topics in mathematics, on physics, on chemistry. Thank you so much. All right. So, all right. So, let's say question from integral in x dx. So when you have something like this, what will you do? First of all, which method of integration are we going to apply? Which method of integration are we going to apply? Which method of integration are we going to apply? Integration by what? All right, so solve it. Solve it. If I solve the solution and you have the same answer, you type, I love it. All right, so I'm going to solve it now. The coefficient of in x is 1. We are supposed to have x here, but no x. So you now say y is equal to integrate 1. When you integrate 1, you get x. Okay, put it inside, minus 1 plus c. So that is the answer. Something like this. you have x in x dx, now you have x. Integrate x. You have x squared over 2 into in x minus 1 all over 2. All right. This is beautiful. Okay. This is beautiful. I believe you've gotten it. You got it. If you got it, you say, I love it. All right. Keep on liking, keep on liking, keep on liking, share the video, share it to different groups, share the video, keep on liking the video, share it, share the video, like and share, like and share, like and share, so people can see it and appreciate it and learn from it. Share the video. All right. Let's see how we can solve a simple question. Integrate 5 raised to power x dx. How do we go about this? When you see this question. So, all right, so I'm going to solve it. If you have the same solution, same answer with me, say, I love it. Okay, so let's solve it. Let's have it. Let's have it. So y is equal to, what will you do? Nothing. Just write 5x over in 5. Okay, that is all. Plus c. This is integration of exponential function. Integration by substitution also. But this time around, you see, 5. See how you understand whether you got it or wrong. Remember, if you differentiate this function, you get back this 5x. So how do we differentiate this? How do we differentiate this? The y dx is equal to what? To differentiate this, you write 5x. This is constant already. 5x dot in 5. So if you differentiate c, you get 0. So this will cancel out this. So your answer is 5 raised to the power x. Have you seen that we have gotten back this 5 raised to the power x? So if you integrate, you get this. If you differentiate, you get that. So to check whether what you have done is correct, you do the integration and differentiation. Differentiate what you have integrated to know whether you're correct, okay? So I would like you to do this. X 3 x squared dx. Oh yeah, fast. All right, so what you do is this. To integrate this, keep this x, 3x squared, keep it all over. Then in 3, then differentiate x squared, you have 2x. That is the answer, plus c. Can this cancel this? Yes. So y is equal to 3x squared over 2 in 3 plus c. All right, so that is the answer to that question. Keep on liking if you understand it. Keep sharing the video. All right, imagine you are given something like this now. Integral sine integral 2 x. What will you do? I'm going to solve it. If you get the same answer, you're right. I love it. Y is equal to 2x over in 2 plus c. That's the answer. Did you get the same thing? Let me see your comment section. I love it. You got the same thing. Say, I love it. All right. So, what is its exponential? What if it's exponential x raised to power 3? Okay, that is not an exponential. That is power function. So we don't have something like this unless you say x raised to power 3. Okay. If you have x raised to power 3 is a power function, the answer is x 3 plus 1 over 3 plus 1 plus c. So nothing like stress for that. So if you have something like this, get this. All right. Okay. Beautiful. Integral x squared 3x3 dx. So that is the question you're talking about. If it's like that, there is no problem. That is exponential function. So what you do is y is equal to x squared, you write it down, 3x cubed, you write it down, over in 3, you write it down, then differentiate 3x cubed, what will you get? Differentiate x cubed, what will you get? You have 3x squared. You now add plus c. Since this we cancel out this, your answer is y is equal to 3x cubed all over 3 in 3 plus c. So this is what you're talking about. That is the correct solution. Ask more question. You are free to ask more question. This is the time for question and answer. After that, we call it a day. Ask your question. I'm here to attend to it. I'll answer all your questions. Ask your questions now. I'll answer them. Ask your question. All right. Okay, let's say y is equal to integral cos x 3 sine x dx. What will you do? How will you solve it? All you need to do, y is equal to, if you differentiate sine x, you get cos s. So cos x sine x over cos x in 3 plus c. This will cancel out this. Y is equal to 3 sine x over in 3 plus c. All right, so that is the answer. Feel free to ask me your question. All right. If you are asked to integrate this, the answer is write down 5 minus 5 all over x raised to the power of 4 plus c. General formula, a over xn dx. Answer is minus a all over n minus 1 x n minus 1 plus c. So use that formula to know it. All right. So thank you so much for participating in today's class. I so much appreciate each and every one of you. Stay tuned for the following class by 7 a.m. tomorrow. See you guys tomorrow morning by 7 a.m. Try to participate actively and have a wonderful day ahead of you.